So this is the new unit. We're talking about functions. Wouldn't it be incredibly maddening if you went and you typed in, you look up which one it is, and you want C4, so you type C4, and it's this bottle of pop right there, and you type C4, and you hit enter, and then it pops out the can of pop, just like you expect. And the next time you do it, to buy one for your friend, you hit C4, and it pops out a different kind of pop. You'd be like, what the heck? 2 seconds ago, I hit C4, and the right kind of pop came out. If you put in C4 as an input, like that's what you type in the little screen here, you're supposed to get a Diet Pepsi or whatever. And instead, you put in a C4 the other time, and it comes out with like an orange. You would be frustrated because that doesn't make sense. It's not consistent. Functions have to do the same thing. If I put a 6 into a function, it can give me any number it wants to, whatever. But if I put the 6 in again, it better give me whatever that same number was. You have to be consistent. So if you have one input, it'll have only one output. This is one input that had 2 different outputs. That is not a function. So that's how a pop machine is like a function. Once you type in C4, it'll pop out Diet Pepsi. It won't give you 2 different functions. All right. Just a quick reminder, this is the part where cell phones need to be away, not even sitting on your desk anymore. And just pop it in your backpack and you won't get in any trouble at this point. All right, so whoever started using f of x was smart. Instead of saying y equals like 6x minus 4, they started saying f of x. And you might be like, I prefer y. Well, they're pretty much interchangeable. But the thing that's cool about saying f of x is you can say what number you stuck in to the function. So like f of 3, you're saying, I'm sticking a 3 in the function. Try to do that with a y. You can't really do that. You can't really put, like, if you say y to the third, you totally just change the answer. You can't do that. So it's kind of fun to say f of x, because then you can say what you just stuck in to your function. But f of x is pretty much y. They are the same thing. They're just a different way to write it, and it's more useful. Here's the other thing. Instead of saying 3 different functions, y equals 6x minus 4, and y equals x minus 10, and y equals 7, those are all functions. It all passed the vertical line test, and they would all, if you put in one input, you always get a different output. They can, instead of saying y, they could call it, well, they are different, aren't they? They're different than each other. So I could say this one's f of x, and I could say this one's g of x, and I could say this one's m of x. You can give them different letters, and yet they're all still functions. All right, so that's some of the advantages of this form. Here are some of the things we're going to ask you to do. If I give you a function f of x, and I say it's equal to 6x, and I give you a different one, would you please write these down? G of x is equal to 10. Would you please figure out f of 3 and then figure out g of 3? And don't let either one of them freak you out. One's easy and one's weird, but you should be able to do it. Basically, that's f of 3 is saying, hey, I just stuck in a 3 where the x was, so x is 3. That's what f of 3 means, is it's saying, hey, I just decided to tell you that x is 3. So then, f function is this one. 6 times 3 is 18. Raise your hand if you had 18 there. Cool. How about g of 3? I know it's weird. You're like, okay, so I stick a 3 in here, and you're like, but there's nowhere to put a 3. That's because they always want the answer to be 10. Whether you stick in 3 or 17 or 0, the answer's 10. So what's the answer? 10. So again, if I stuck in 3, I get 10. If I stick in 4, I get 10. If I stuck in 5, I get 10. And some people feel like that's not a function. It's a function. Because it would pass the vertical line test. Let's take just a second and say, if I stuck in 3 and got 10, that's like the point 3 comma 10. If I stuck in 4 and got 10, that's the point 4 comma 10. This is the 0.5 comma 10. If you graphed all of those, 310, 410, actually, I should be a little more to scale. There's 310, there's 410, there's 510. If I kept going, is there anything wrong with that? No. It can be a straight line like that. That's the line y equals 10. Do you get y is always 10? I don't care what the x is. X can be anything you want, but y is going to be 10. Is that a function? Yes, it passes what's called the vertical line test. So, if I draw a vertical line through it, it doesn't touch it twice. Vertical lines, though, they fail the vertical line test because, look, it's like if I stuck in the number, let's say that's 7 there. 1, 2, 3, 4, 5, okay, I guess 6. That's the input of x is 6. I got 6 comma 1 right here. I got 6 comma 3 right here. I got 6 comma 10 right here. Do you get that that fails the vertical line test? If I draw a vertical line through it, it hits multiple times. And one input, different outputs. If I go to the pop machine and I type C5, it better give me the same pop as last time. This one's giving me different kinds of pop. Every time I put in 6, it gives me something else. It's not like this doesn't exist, it's just not a function. This is the equation x equals 6. See, because they're all 6's where the x's are. So this is the line x equals 6. That's not a function. Doesn't pass the vertical line test. All right, does this pass the vertical line test or not? No. Because if I put in one input of, let's say that that's at 1, 2, 3, 4, 5, 6, 7. That's at 7. It gives me two different outputs, that and that. In fact, if I put in input of 6, it would give me 3 different outputs. This, and this. You put in an input, you're supposed to only get one output. I'm getting 3. That fails the vertical line test. That red thing, not a function. All right. A lot of people get confused on this one. Function or not a function? Go back to the vertical line test. If you put a vertical line through it everywhere, is there ever a time it says 2 different things? No. I know there's a gap in it. You know what that means? This function is not continuous. It's called continuity. It was going along and all of a sudden it just stops working. There are functions that actually do that. And they're still functions. It's okay. You can do that. Here's another tricky situation. It's going along, stops working, starts working again right above that, and then keeps going. There are functions that do that. Is it continuous? No. Is it a function? Does it pass the vertical line test? Yes, it does. Now you might be thinking, what about this spot right where they line up? Well, in the one place it's specifically empty. So this is passing the vertical line test. It's not defined right there. It is defined right there. Passes the vertical line test. Is it continuous? No, not continuous. Because a way to think of continuous is, if you were drawing it with a pencil, would you have to lift up the pencil? Yeah, you would. So then it's not continuous. Okay, so you now know a little bit more about functions. So what if I said f of x is 6, period. What if you put in a 2? What are you going to get? What if you put in a 6? What are you going to get? 6. And again, I know it's weird, but if you were not sure if it was a function or not, what you should do is graph it. And you make a few points like, okay, if I put in 2, I get 6. I put in 3, I get 6. 4, I get 6. And then if you just go graph it quick, over 2 up 6, over 3 up 6, over 4 up 6. Oh my gosh, yeah, that kind is okay. It passes the vertical line test. All right. So here's another weird thing we can do with functions. What if I say, I want f of x to be 6 and g of x to be 4x minus 7. What if I say, I want 3 g of x? Now, some of you think I just said g of 3. I did not. 3g of x. Do you get the idea that's 3 times the g function? 3g of x. There's a implied multiply. Anytime, you can trust that. In this class, if there's two things right next to each other, and there's nothing there, that means times. It's implied. Okay, so that's 3 times g of x. So all you got to do is take this and times it by 3. What if I said 3g of 4? Well, now, you got to stick something in the function. What are you sticking in the function? A 3 or a 4? 3g of 4. Everybody give your best guess what that answer is. Don't say it. Figure out what you think the answer is. The answer is just one thing. It's like 28 or something. Figure out what you think 3g of 4 is. And then compare with the person, and I hope you haven't forgotten their name, and if it changed, because sometimes seating charts change. Remind yourself what that person's name is. These two rows, straight across. These two rows, straight across. But in your case, you got that long distance thing. I appreciate it if you fits it over here, and he has a partner. Okay. And now, you two right next to each other makes logical sense, and you two compare. You three compare. Okay, go ahead, compare. Do you notice we don't even use this? The f function wasn't needed to do this. Just the g function, and then where do you put the 4? Some people get confused. Do you put it here? Well, that's not really wrong. I want g of 4, right? So g of 4 is, but if you only put the 4 there, then you'd have a problem. You also put the 4 here. So then it ends up being 16 minus 7, which is 9. But then you got to do 3 times that, 27. Who actually had 27? Cool. Let's make sure you get that. We stuck a 4 into the g function. 4 times 4 is 16 minus 7. 16 minus 7 was 9. Then 3 times that. 3 times the 9, 27. Yes?
Can you get rid of the 3? Or is that just part of like the final equation?
The final answer here is 3g of 4 is 27. That's what you would write. You wouldn't write any 3. What you could do if you wanted to show your work better is this. 3 times, and what was g of 4? Remember what g of 4 was? What is g of 4? It was right here. What was g of 4? What's that? When you actually stick the 4 in, though, it's not x anymore. It was 4 times 4 is 16. 16 minus 7 was 9. So this was 9. So then 3 times 9 is 27. That's how you'd show your work a little better. Yes?
Do we keep the 3 in the 3gx? When we get our final answer?
When you say it's in the 3g, it's not in it. It's right in front of it. That 3, that's in front of g of 4.
Yeah, so do we keep it in our final answer, or does it like cancel out?
Okay, so then what was g of 4 again? G of 4 was 9. And so now we're left with 3 times 9. And what is 3 times 9?
27?
27. Do you think I should times it by 3 again?
No?
No. This is it. It's 27. That's your final answer. Just 27. The 3 was in the final answer because you did 3 times 9 to get the 27. All right. All right, so let's do one more. I think after this you'll get it. F of x is x squared. G of x is 5x minus 1. Figure out f of 2, g of 3, and 5g of 2. There's 3 answers. Some are easy, some's harder. Compare your 3 answers with the kid next to you. Wait till they're done. Pause for a second. May you give this one a try. All right, so you should have stuck 2 into the f function, and then you would have had 4. Raise your hand if you had 4 for that first one. Okay, good. Stuck in a 3 here, and that's the same as a 3 here. G of 3 is 15 minus 1 is 14. Raise your hand if you had 14. Okay, good. And the last one, G of 2. So first I stick a 2 in. G of 2 is 5 times 2 is 10 minus 1 is 9. That's the answer. That's not the answer. That's 9. And that's 9. And then 5 times the 9 is 45. How many of you had that one right? Cool. Now, using that same data, would you please tell me what 5g of 2, don't reinvent the wheel, you already know what it is, minus g of 3 plus f of 2 is? We already know what each of them are. We know what 5g of 2 is. It's right there. I know what g of 3 is. It's right there. I know what f of 2 is. It's right there. So didn't I really just say what's 45 minus 14 plus 4? Isn't that pretty much what I said? Yeah. Because we already had the answers right here. 45, 14, and 4. So what's 45 minus 14? Well, that would be 31 plus 4, 35. Who had 35 for your answer? Cool. Okay, you get it. Now, could we make it more complicated? Of course. You can always make math more complicated. Let me throw a couple of the curveballs at you. So, new 3 functions. Find another page. F of x is 3x. G of x is x squared. What if I said, what's f of m? If I just said f of 5, you'd have just stuck 5 in the function. But just because it's a letter, a lot of people freak out. You're just supposed to stick m into the function. Which function? Did I ever say g? No, so it's clearly not the g function. So stick an m in the f function. Where would you put it? Well, it's really only one place to put it. Where would I put the m? F of m. And if I just did that, all I did is label it. F of m is, well, you got to put it here also. 3m. So yeah, you can stick letters, variables, in your function. And you want to go really weird, then you can stick functions into functions. Well, let's keep this as f of x is 3x. I'm just erasing what I had, so it's still the f of x is 3x. What if I said f of g of 2? Whenever you have a nest problem, nested parentheses, go into the inside and then work your way out. Remember, I told you if you get stuck on a really hard problem, just go one step at a time. So what's your first step? Stick 2 into the g, the g equation. Stick 2 into the g equation. I'm sticking 2 in there. And what do you get when you do g of 2? Brady, stay with me. G of 2 is 4. Okay. You get how I got that? I stuck the 2 in here. G of 2 is 2 squared, so 2 squared is 4. That's 4. Now what do you think you have to do? F of 4. So f of 4 means you're going to stick 4. Now the new problem is just f of 4. F of 4, stick 4 into the f function, and you get f of 4 is 3 times 4, which is 12. Raise your hand if you had 12. Okay, cool. All right. And there's one last way that it can get weird. And that is like this. We're going to leave the same 2 functions up there because I want you to be able to not have to like make another set of functions. This is still just going to be x. So if I say f of x equals 27, somebody smart is going to figure out what you can figure out. It says f of x is 27. What can you even figure out from that? Can we figure out the answer? No, the answer is 27. What can you figure out? X. What do you think x is? X is 9. So how'd you get that? Would you agree that f of x can be replaced with a 27? They are the same thing. F of x is 27. Remember, f of x is kind of like a y. It's just a variable. F of x is like y, and y is like 27. So wherever you see f of x, which is right here, I can put a 27. So 27 is 3x. So what's x got to be? 3 times 9 is 27. X must be 9. All right, we're going to do another one, but this is going to take extra smart kids. See if you can handle it. G of x equals 9. Some of you are like, oh, that's easy. It's just this. If it's that easy, you did something wrong. He's got it. Tell the confident man.
Can I just go to the bathroom?
Oh, boo! It was a confident hand. But yeah, you can. You just got to bring your pass up. Remember, show me that you're using it up. Pro way to do it is to, because they can ask you for your pass in the hall. So I would bring your phone with you. And that is the correct time. Go ahead. But you can bring your iPad if you want, but if you bring your phone and you actually get your pass on your phone, then you just have to bring your phone, because what you were probably going to do anyways when you go to the bathroom, right? Okay. All right, so g of x is 9. G of x is x squared. Therefore, since g of x is 9, I just put a 9 here. 9 equals x squared. X squared equals 9. Oh, the answer is 3. No, it's not. Think deeper. Yes.
You have to square root both sides.
So, you're right. So, why isn't the answer just 3?
I should know.
Absolute value. So then what? Why isn't the answer just 3?
Plus or minus 3.
Yes, because it's 3 and it's -3. Hey, you decided to take honors. You wanted the easy, could have just been in regular, and then there would have only been one answer because we would not have given you that problem. All right, so when you have something like this, it's very tempting to just get one of the answers. 3 squared is 9, I'm done with 3. Nope, -3 also works. When you square up both sides, you get a absolute value here, which forces you to get 2 answers. All right, we've made it. You're at the end. I skipped a ton of slides, which are going to save you a ton of time. So I want to just actually get to the homework. There is a separate file in there with the homework in it. Did you remove the headphones? Thank you. It's almost time to put them back in, but not quite yet. So find the worksheet. I'm going to ask you to read me a problem. I think it's big enough I can skip a couple, but I need to see it first. Could you read me numero uno?
F of 7.
All right, and to do that, it kind of begs the question, what's the f function? Which must say above, what is the f function? Does it say f of x is?
Yeah, 3x minus 4.
And so, really, they want me to stick a 7 into that function. So, f of 7 is 7 times 3 is 21 minus 4. What is 21 minus 4? Well, it's like 20 minus 3, so I think it's 17. Anybody agree with me it was 17? Okay, cool. All right. So, let me just see if I can find that kind of unnecessary. Let's skip G. And J, and do the rest of them. And I know there's going to be some questions, but that's part of the beauty of leaving you work time. Skip G and J, because those will be pretty easy. And do the rest, and you have a bunch of time to work. Okay? All right, that's all I got for you for the video for today, and I'm now about to hand the test back now.